Hello, welcome to Pre-Calc A. We are going to start Pre-Calc A off this today with section 1.3, which is talking about linear equations in two variables. We're talking today about lines. I'm going to start you off with an introduction problem where we're asking you to graph a line, and this is something we did in Algebra 2. We want to talk about things such as the x-intercept, the y-intercept, and the slope. And so I'm going to start with the slope. The slope is always the number directly in front of the x. And so in this case, the slope is 3/2. The y-intercept is always the b value. And if you remember the general equation of the line, the general equation for lines is y equals mx plus b, where m was our slope and b is our y-intercept. And so our slope was 3/2. Our y-intercept then is -6. And we're looking for one more thing which we normally do not ask you in a line, but we're looking for the x-intercept. In order to find the x-intercept, we're going to make the y value be 0. So I'm going to set this equal to 0, and I'm going to say 3/2 x minus 6. In order to solve this, we're going to add 6 to both sides. So 6 equals 3/2 x. And please do not divide by a fraction. Instead of dividing by a fraction, you should multiply by its reciprocal. So the reciprocal that we're going to multiply by is 2/3. And if I multiply 2/3 on either side, you should get then that x is 4. And the interesting part is, again, what does an intercept mean? An x-intercept is where we hit the x-axis, and a y-intercept is where we hit the y-axis. In Algebra 2, we asked you to graph this equation, and in Algebra 2, we said always start with the y-intercept, and so I'll go on the y-axis down to -6, and I'll plot a point. And from there, we suggested in order to graph the line, you should move by using your slope. And your slope you're used to hearing is rise over run. And if you're talking rise over run, they're saying basically how much did you move up or down over how much you move left or right. And so the 3 is positive for our slope, which means I'm going to move up 3. And the 2 is positive, which means I'm going to move right 2. And so this is the new point that I get. And I'm going to keep doing it as long as I can. So up 3 over 2, I plot a new point. Up 3 over 2, I plot a new point. And I continue to keep going until I can't do that anymore. And I connect the dots and extend it with arrows. Please remember a line goes on forever, so the arrows are important. And if you notice, then this y-intercept here is -6. And this x-intercept right here occurs at a +4. And so as you're looking, everything that we just did can be done too by just making a graph. And we will ask you to graph these. If possible, we want you to do them without a calculator. So that's kind of the overall view of where we're going today. We're going to be using perpendicular lines and parallel lines, and we're going to be mixing a bunch of lines together. And so what I would like to do is talk about the general idea of slope. So I'm going to move this up and we'll give you a picture that your book describes as to slope and what it means. So let me slide this around a second. What I want to do is talk about general slope form. Slope-intercept form of a line we talked about already, but it's y equals mx plus b, where m is the slope and b is your y-intercept. Okay, let me give you a picture to kind of illustrate, and this is a picture that you saw in Algebra 2, but we want to give it to you, I guess, in more general terms. And so we pick 2 points. Let's say I pick a point here and I pick a point out here, and it doesn't necessarily matter where your points are. I'm going to label my first point as x1, y1. And I'm going to label my second point as x2, y2. And we're going to give you basically the picture representation for what slope means. And so as I go through, I'm going to draw this line connecting the 2 points. And then from these 2 points, I'm going to draw a right triangle. And a right triangle, again, meets in a perpendicular line, or perpendicular angle, sorry, and so you're looking here. The distance at the bottom is the change in the x's, and the way we find it is by starting with x2 and subtracting x1. And the vertical distance is the change in the y values, and we find that by doing the second y value here minus the first y value over there. And so if we start talking about the formula just for slope, we originally described it as rise over run, which if I look at the rise is the up and down value, which is y2 minus y1, all divided by the run, which is the horizontal distance, x2 minus x1. Now, this slope formula is something you should already know. If you don't, please make sure this is something that you know, because as we go through, we're going to make sure that you can accomplish slope in a set of different problems. And so we're going to go through parts A, B, and C to find the slope, and then from there we'll graph the lines and see what each looks like. So let's take a look at these examples. If I label this, and sometimes to help I label this x1, y1 and x2, y2. It doesn't necessarily matter which point you label, as long as you label, one point as the first point and the second point as the second point. But take a look, y2 minus y1 says -2 minus a -4 over -3 minus 5. Well, subtracting a negative is the same thing as adding a positive, and so this is 2. -3 minus 5 is -8, and we always reduce fractions. You get -1/4. Now you will notice I moved the negative from the bottom to the top, and it doesn't necessarily matter where the negative is, as long as it's in one of the positions. I will tell you personally though, I always put my negative on top. Okay, now if I grabbed these 2 points, and I go to -3, -2, I get this point. And if I go to 5, 4, 5, -4, I get this point. And if you draw your line, you will notice that the line seems to be decreasing. It's going in the negative direction. That means this line falls. And they will sometimes ask you to classify these as you're going through, but I just want to give you an idea of what that actually means. So we're going to find the slope for 2 other ones. Take a look at the second example, part B. I'm going to go y2 minus y1. So 5 minus 5. And I do my second y value, which is -3 minus 6. Well, 5 minus 5 is 0. -3 minus 6 is -9. 0 divided by anything, though, is 0. Please do not leave your answer as a fraction because it can be simplified. Now, if I graph these 2 points, 6, 5, and -3, 5, and I connect this and extend my line, what type of line do you see? This is a horizontal line. Okay, and if you were to describe this slope, you would say it has no slope. It is a slope of 0. Okay, the last example, we'll do one more, and then we'll actually solve some, set up some equations. If you take a look, y2 minus y1, -2 minus 5 over -2 minus -2. And if you look, on top you get -7. In the denominator, subtracting a negative means add a positive, you get over 0. You cannot leave a fraction with a denominator of 0 because you can't divide by 0, you get something that is undefined. please make sure that you write undefined. I will not accept the -7 over 0. It does have to be simplified, and the only way to simplify it is to say it's undefined. If you look at these 2 points, -2 is here, -2, 5 is up here, and if I connect the 2 points and extend, you end up getting a vertical line. Okay, so vertical lines have undefined slope, horizontal lines have a 0 slope. So as you're going through, again, part of the homework will ask you to find slopes. You will need to show work going through like we just have. You won't always have to graph it, and the goal is to not have to graph the line in order to be able to see and classify the slope. We're going to flip the page over and look at the second side where we start talking about writing equations of lines. And you have 2 ways to write an equation. You can write it in point slope, and you can also write it in slope intercept. And you're more comfortable with slope intercept, and I will show you both as we go through, but I really do like point slope because it's not a multiple step thing. This point slope, I'm actually going to change this and make this an equation. I'm just going to give the equation to you. You did learn it in Algebra 2, so I'm just going to kind of give it to you. It goes like this. Y minus y1 equals the slope m times x minus x1. And I'm going to classify this a little bit. M is the slope. We've already talked about how to find that. And then you are given a point, x1. I can get my pen to work. x1, y1 is a point. And that's why we call this point slope, because we will give you a slope and a point to use to write your equation. And so what I want to do is go through one example, and then we'll kind of mix point slope and slope intercept, and you can kind of decide which version you like. No matter what, your answer should be in slope intercept form. So given this first example, we're telling you it passes through 2 points. No matter what type of equation you're using, the first thing you have to have is slope. So in order to find my slope, let me go back to my slope equation. Y2 is 5 minus y1 is -1 over 3 minus 2, which is my x2 minus x1. Well, subtracting a negative means adding a positive, so you get 6 over 1, which is just 6. Please don't leave a fraction over 1. And once I have my slope, I'm going to show you how point slope works. Point slope says take the normal x and y in your equation, so take the y and subtract the point, the y coordinate of the point. Now you may choose a point. I'm going to pick 3, 5 personally because it's positive. So as I look at this, I'm going to say y minus my y value. So y minus 5 equals my slope of 6 times x minus my x value, which is 3. And from here, all I'm going to do is to simplify it so it's back in slope-intercept form of y equals mx plus b. So I'm going to distribute this out, and I'm going to say, and I'm going to add 5 at the same time because I don't know you guys know how to solve these. So y equals, if I've got 6x minus 18 and then a plus 5, my final equation is y equals 6x minus 13. And what I love about point slope is I don't have to find the b of 13 and then plug it back into my equation. It's already there for me. So I'm going to continue with point slope. If you're interested more in doing it with slope intercept form, please make sure you stop and say something to me at some point so we can go through that. So this is the first idea where we're talking about general equations of the lines, and you did this in Algebra 2. However, in pre-calc, we're going to get a little bit more difficult, and we're going to start introducing parallel and perpendicular at the same time. So let me move on to that section. You slide to the bottom of your notes. As I look at this, here is the most important thing. You must know these ideas or you will have a difficult time in this section. Parallel lines do not cross, and therefore the slopes are the same. Okay, parallel lines do not cross, and in order for them to not cross, the slopes have to be the same. Perpendicular lines will cross at a 90-degree angle, and those lines have slopes that are opposite reciprocals. Remember, opposite says if it was negative, it's now going to be positive, or if it was positive, it's now going to be negative. And reciprocals flip a fraction so that if your normal value is 2, the reciprocal would be 1/2. And so keep that in mind, and we're going to go through a couple examples. Okay, as I'm looking at this, I noticed that these notes are slightly different than the ones in your packet. So what I'm going to do is switch over, and I apologize for this. I am going to switch over so that you can see the ones that I was hoping you would see. So let me slide down a second as I do this. And I want to look at 3 points. Keep in mind that a parallel line has the same slope and a perpendicular line have opposite reciprocal slopes. And so given this first equation, we are talking about the fact that we want our lines to be perpendicular. And they give you one line to start, 2x minus 3y equals 5. Can you tell immediately from that equation what the slope is? Most of us would say no. And so in order to do that, what we're going to do is we're going to rewrite that equation in terms of y. So I'm going to subtract 2x from both sides, and I get negative 3y equals negative 2x plus 5. You could, if you would like, say 5 minus 2x, but normally we write our slope in the first position and our y-intercept in the second. So I'm going to keep it going that way. If I divide everything by negative 3, my equation then is a positive 2/3, because a negative and a negative cancel, to a positive minus 5/3. And truthfully, all that we need from this equation is the original slope. Because if I'm looking at a perpendicular line to this, perpendicular slope would be the opposite and the reciprocal. And so the slope that I want for this line is the reciprocal of 3/2, and because that's positive, I'm now going to make it negative so that I know it's perpendicular. So I take this slope and the point to -1, and I'm going to put that into point slope to find my equation. So y plus 1, because it's minus the y value, and since it's already negative, it turns positive, equals negative 3/2 times x minus 2. So basically you're putting the opposite in with the value as you go through. I'm going to distribute this out and also subtract 1 kind of at the same time. So I have negative 3/2 x. Negative 3/2 times negative 2 is a positive 3, and then minus 1. And all I have to do now is simplify. Negative 3/2 x plus 2. And this now is a line that will be perpendicular to my original y equals 2/3 x minus 5/3. And as long as their slopes are opposite reciprocals, they will end up being perpendicular. So we're going to go through another one, a parallel one, and then we'll look at a story problem. Same thing, we have now a parallel line, which means we need the same slope. I again solve for y. What I find is y is negative x plus 7. Negative 1 then is this slope. Because I want a parallel line, I want to keep the slope of negative 1. So with a slope of negative 1 and a point of negative 3, 2, I'm going to put that again into point slope. Y minus 2 equals negative 1 times x plus 3. Again, it's always the opposite because we're subtracting the negative. I'm going to distribute and add 2 at the same time. Y equals negative x minus 3 plus 2. So y equals negative x minus 1. And this will be parallel because both equations start with a negative x. And we will be doing more of these in class. I want to make sure that you understand before we get to class so that we can practice a few together. I have one story problem for you and then we will be done. If you take a look though, we talk about a car. A 1998 base model Honda Civic cost $12,000. 8 years later, I decided to purchase a Civic for $2,000. What's an equation that could describe the value of the car each year? What they've actually given you is 2 points. At time 0, or basically the start of this question, my Honda Civic cost $12,000. At time 8, or 8 years later, my Honda Civic cost $2,000. And given these 2 points, you should be able to find the equation. And I'd like you to try that on your own. So please pause the video and take a second and figure out both the slope and then your slope-intercept equation. Okay, now that you've had a chance to look at this, the equation that you should be getting is y equals negative 1,250x plus 12,000. And if this isn't an equation that you were able to get, we will start tomorrow's class by going through questions, and so I will gladly go through and explain. So thank you for watching this. Please make sure you are ready and prepared for asking questions in class tomorrow.